All right, guys, welcome back. Fractions and Ratios, Series C. Today we're looking at ratios and proportions. Okay. First of all, let's define a ratio. What is that? And really simply, a ratio is just a comparison of two items. For instance, we might have something like 8 boys and 12 girls in our class right now. So if we wanted to make a ratio of those, we could say that the ratio of boys B to girls, what is the ratio of B to G, boys to girls? It's 8 to 12. Another way we can write that is 8 colon 12. Okay? Those are two of the ways you'll see ratios written. It's a comparison from boys to girls. But the way we normally write them, and most of the time we'll see them, is as a fraction, like this, 8 over 12. And again, that's the boys, 8 boys, and the girls. Okay? Now notice if it's written as a fraction, we can also use it in a similar way as a fraction, so we could reduce this. We've been doing that this week. We can divide out the common 4, that's a factor for both 8 and 12, and we'll end up with 2 over 3. Is that true? If there are 8 boys and 12 girls, is it also true that for every 2 boys, there are 3 girls? And yes, that is the case. If we were to draw out eight boys and then 12 girls, we can see for 8 boys and 12 girls, we've got 2 boys for 3 girls over and over, which means that ratio is true, both as the original fraction, 8 to 12, and as the reduced fraction, 2 to 3. So it's just a comparison of boys and girls. All right, moving forward. Let's have you, real quick, do a few practice ratios. I went to the market today, and they had 15 pieces of salmon for sale. I love salmon, don't you? 12 pieces of pike, northern pike, and 6 pieces of trout. So let's have you guys write up a few ratios. What would the ratio of salmon S to pike be? And make sure it's reduced for me, would you? What about the ratio of trout to all fish? Everything they had at the market. Write that out. And then how about the ratio of pike to salmon? Write that one out, pause it, and write those 3 ratios. Use the fraction form. Go. Okay. S to P, salmon to pike, 15 to 12. Now, that's the start, but I want to reduce that and be able to see what the reduced ratio is. I see there's a common 3, so if I divide out that 3, I get 5 to 4. So it turns out that at the market, for every 5 pieces of salmon, there's only 4 pieces of pike. Okay? T, trout to all fish. Well, if there's 6 trout to all fish, I'd have to add up. How many fish are there total? 5 and 6, 11, 12, 13. 1, 2, 3. There's 33 total pieces of fish. So there we go. And again, what is that ratio when I reduce that down? Divide out that common 3. Okay, just show you what's going on there in case you need some help there. And it turns out there are 2 pieces of trout compared to every 11 total pieces of fish. And notice I did include the trout when I added. When we say all fish, it's also including the trout. So that ratio is trout to everything. All right, P to S, which is pike to salmon. And notice, we already did that. But it does matter with the direction we write things. So P, pike, 12. S, salmon, 15. And notice, that's different than what we had a minute ago. 15 to 12 is not the same as 12 to 15. So you need to notice and remember the order when you write these out, okay? And if we reduce that down, again, there's a common 3. I'm sure you noticed with all of these, that's a pattern on this set. Let's stick with green. Take out that 3 from 12 is 4. Divide that 3 out of 5 is 5. And notice, they're going to reduce the same. It's still a 5 and a 4, but the 5/4 is different from 4/5. So the order does matter. So that's the basic idea of ratios. You're just comparing them, and you're writing those two values as a fraction. Let's now use these in proportions. All right, so let's talk about proportions here. I'm going to make a recipe for disaster. Watch out. And in my recipe for disaster, it calls for 3 cups of flour and 6 cups of sugar. Now, what if I ended up making so much disaster, I made multiple batches of it, that I ended up using 24 cups of sugar? If I needed 24 cups of sugar for however much I'm making, how much flour are we going to need? Let's use our variable. We need X cups of flour. How much is that going to be? What would X be to be able to make that recipe? Now, you might be able to, in your head right now, jump to 12. And if you did, you're correct. This is a very simple numbers kind of problem, though, so we can do it in our head, we can see it, and then we're going to apply it to more challenging numbers in a second. So you still want to watch and understand the concept so we can use it in a minute with harder stuff. Okay, I'm going to write up the first ratio right here, 3/6. Now it's important, really important here. Notice what's on top, what's on bottom. The way I wrote this up, I put flour on the top, and I put sugar on the bottom. And an interesting thing about proportions is that which is on top doesn't actually matter. What matters is that you choose something to be on top, and then you make sure that stays on top. You don't mix things up. So I put flour on top, so when I go across and I write the other proportion, I need to make sure flour's on top and sugar's on bottom. And it turns out I don't know how much flour. We're going to call it X. But I do know it was 24 cups of sugar. So now I wrote up 2 ratios. The original ratio of just a single batch, and I've got another ratio of some larger number of batches, and I want to figure out how much flour I need. Here's the key thing. That's what makes a proportion. A proportion is setting 2 ratios equal. Let's write that down. Okay, and in this case, they are equal. We're making a larger batch. We've just scaled up the amount of sugar, so we know they're equal. We just want to know how much flour that's going to be. We're going to use this framework right here, 2 fractions set equal, to be able to figure that out. And I'm going to show you a couple different ways to do it. Whichever one makes sense, you can use. All right, first thing I want you to notice, we can go straight across because these are just 2 equivalent fractions. So if we can see what the multiple is that we used to turn 6 into 24, we have what we need. And it turns out it's 4. So just like we talked about numerous times this week, as soon as I can find my highlighter, if I'm going to multiply by 4 on the bottom, as long as I multiply by 4 on the top, it's still going to be an equivalent fraction. It's still going to work out. So I can just multiply 3 times 4, and I can see that x equals 12. I've found the common multiple. That's a way to solve the proportion. Okay? That's one way to do it. Now, let's look at another way we can do it. As soon as I, again, find my tool, there it is. Let's move all this out of the way so we can have it on. Okay, all I did was copy the problem. And now we're going to erase the work we just did. And it doesn't work. All right, we'll erase up here. Okay, we'll rework the original top version and use the bottom one as the example that we just did. So, exact same problem. Let's look at it another way. We can also look top to bottom. I can ask myself, what turns 3 into 6? Okay, what's that multiple? And hopefully, really easily, we see 2. Well, it turns out that'll also be a true relationship on the other ratio, the other fraction. So if I can multiply by 2, or if I can learn to use the highlighter, if I can multiply by 2 there, I can do the same on this side. And so now the question is, what times 2 equals 24? Oh, 12 times 2 equals 24. And there's my second way that I can solve, okay? So it turns out there's 2 relationships. I can either look across and just think of it as equivalent fractions. What's the multiple I can use? Or I can look top to bottom with the exact same idea. What's the multiple top to bottom? And that's valid for both as well, okay? There is even a third way, which is cross-multiplying. I can show you that in a minute, but let's not do all 3 at once and confuse people. Let's just do a little practice here. So if I said something like that, could you figure out what y equals? And could you do it through both methods? Try going across and try going up and down. Go. All right, if we're going to go across, we're going to ask ourselves, what's that multiple? If I'm just thinking straight up like an equivalent fraction, what did I do to turn 3 into 9? It's a multiple of 3, which means it's also going to be a multiple of 3 here. What's 3 times 24? It's 72. Okay, there's the first method. Let's do the other method. We can ask ourselves up and down. What multiplies to make 3 on the top, 24 on the bottom? And that's a multiple of 8. So if I come over here, I do a multiple of 8, and 9 times 8 is also 72. Okay? Both of those methods work. Now, the third method, if you want to use it, and to be honest, I like using the first 2. I don't use this third method, but a lot of other folks do. So I'm going to show it to you. Pick the one you like. The third method is that it will also be true that if we cross multiply on 2 equivalent fractions, which they are equivalent, we've already set them equal, they're already a proportion, then those are going to be equal to each other as well. Let me show you a simple example. We know that 6/12 is exactly the same as 1/2, and since we know that those are equal, that is true. Watch what happens. 6 times 2, go the other way, 12 times 1, and what do we see when we multiply 6 times 2 is 12, 12 times 1 is 12, so cross-multiplying also works every time, okay? So if we wanted to use that on this problem, we would do 24 times 9, and we know that that's equal to 3 times y. 24 times 9, I don't know off the top of my head. I'm going to have to work that out. It's 216. And so now we would have to ask ourselves, 3 times what is 216? And you would just have to do the division, and that's going to get us our answer, 72, that we just saw a minute ago. Now in this problem, it was a bit more work to do cross multiplying, but that's not always the case. Any of those ways will work. So you can look for the ratio across, you can look for the ratio top to bottom on one of the fractions, or you can cross multiply. Now, I'm going to try and dive right into the homework and do some of the homework type problems with you right now so you can have examples of the actual homework. I know that that hasn't been the case lately. Some of the homework problems seem tougher, so let's do that. All right, here's your homework for today. Let's take a look at some of the stuff you'll be trying to do, and we can apply the methods that we're learning. All right? I'll do this one right here to start. Now it says replace that dot with the equal or not equal sign. So the question is, we want to know, are these two values equal? And there's basically two types of problems they're going to throw at you with proportions. They're going to give you two fractional values, and they're going to ask us, are those in fact equal to each other? Are they equivalent fractions? Are they a proportion or no? And the easiest way to solve these by far is to apply that cross multiply method that we just talked about a minute ago. Okay? Because if they are equal, then if I cross multiply the two values, I'll get the same answer. So if I multiply the 15 times the 2.4, it's going to give me 2 times 18. And that's by far the easiest way to do this type of problem. 2 times 18 is 36. And here, I'm going to give you guys permission to use a calculator on this lesson, okay? So you can go to a calculator because there may be a lot of fractional, or decimal and larger values, and go ahead and work that out. I'm just going to do it right here because I don't mind. Where did I get 360? Oh, yep, I do get 360. And I've got 1 decimal, so when I move that 1 decimal over, I end up with 36. Okay. When I cross multiply, they both equal 36. What does that tell me? It tells me that these are, in fact, equal. So I can go back in here, and I can say, yep, they're equal. Okay? That's how you would do that type. Anytime they ask you, is it true that it's equal? You can just cross multiply to do that. Why don't you guys try this one right now? I'm going to give you a minute to try that one, and then I'll do it for you in just a sec. Go. All right, let's do it. 2 over 1, 15 over 7.5. So I'm going to multiply 2 times 7.5. And now I'm going to check 1 times 15 and see if they're equal. 1 times 15 is 15. 2 times 7.5. Hopefully you can do that without a calculator. It is 15 as well. So, oh, look at that. They, in fact, are the same. So it means that is a proportion. They are equal. Okay, let's jump to the next part. All right, let's try one of these problems, guys. I'll pick something harder. Let's do this guy right here. 3.2 over 4.8 equals 6.8 over y. Now in this case, notice there's now a variable. There's something missing. So this is a different type of proportion problem they want you to do. They want us to figure out what y is. So we're no longer being asked to check and see if they're equal. They are equal, we know that. We need to figure out what the y value is to make them equal. So now we're solving. We need to get what y is. And again, cross multiplying is really the best way to do this type. If it's something like this, where there's decimals and you can't just see the answer off the top of your head. So in this case, we're going to want to do 4.8 times 6.8. And that's going to be equal to 3.2 times y. Those are going to end up being equal, so I just solve that for y. I'm going to get the answer for y in that original proportion. So I'm going to go to a calculator. I'm going to figure out what the 4.8 times 6.8 is. You guys can use a calculator on these as well, just for the sake of time. And I get 32.64. Now, next week, we're going to start talking about how to solve equations. But for the moment, you can think of it as 3.2 times something equals the 32.64. So what we're going to need to do here is divide by 3.2. We're going to need to I'm going to draw it as a fraction bar. I'm going to divide the 3.2. I'm kind of borrowing from the lesson next week. To figure out what y equals, we just need to divide off that 3.2. So I've still got the 32 in my calculator. I'm going to divide by 3.2, and I get 10.2. So it ends up that the y equals 10.2, and that's what makes the ratio equal. Okay, I could plug that right in there, and now it's a true ratio. Let me show you another problem. If it happens to be something a little easier, a little more intuitive, let's look at, say, there's only one easy one up here, so I guess I'll just do that one. I guess tonight you won't have any of the easy ones. You'll have to use your calculator for all of them. They're making all of these the more challenging type tonight. But if you see something like this, notice you guys don't have to use cross multiplying anytime you can see it on your own. Hopefully you notice 5 times something equals 25. That's a really easy multiple, okay? So always look to check for that. If you see an easy multiple, we know that that's going to be 5. So now we just ask ourselves, what times 5 equals 35? Hopefully that's obvious that it's 7. And again, we can always check the side ratio as well, the up-down on any of those. And in this case, that's not very helpful. 25 does not become 35 very easily. That's not with a whole number. But if that did work, you could use that one as well. So anytime there's simpler, smaller numbers, and you can see the whole number value that's multiplied, I would say this type of method is easier, but otherwise I would cross multiply. All right, let's do one more. How about this guy right here? So they say write a proportion and then solve. So notice we've got 100 candy. And some of you might get hung up on what to put where. You don't have to worry about it. I'm going to put candy on top. It doesn't matter if you put candy on top or bottom, just that it's the same for both sides. That's all that matters. Okay, 100 candy in 3 bags. So there's my first proportion here, 100 candies in 3 bags. I'll put the other one on the other side. 300 candies in D bags. So what is D? Now, here's an example of pretty darn easy. They kind of gave this one away. What's the multiple? So what is D? If you can see it, you don't even have to grab a calculator. It's times 3. So D must be 9 bags. All right. We're going to call it good there today, guys. Do the homework.